Okay, so so the next thing that we're going to talk about is how the stack dynamic variables work in subprograms and how the stack in general works in subprograms. So subprograms and the stack. Now, when I was a lad, first learning how to program, one of the things that I found really challenging was getting a visceral understanding of how recursion worked. And I think that the challenges that I had understanding recursion had to do with my inability to understand how it was that programs actually implemented recursion. And that's because I really didn't understand how subprograms used the stack to operate. So I'm going to give you a little piece of code, and what I'd like you to do is I'd like you to draw for me what the stack looks like with this piece of code. All right, so here's my program. Void sub double total and int part. And then inside here we have a list, which is 5 integers, and we have a double sum. And then we have some more code here. So what I want you to draw is, what does the stack look like if we make a call to sub? All right, so what does the stack look like for sub, basically? All right, and why don't you take a shot at doing that right now? So hit pause and then unpause, and we can compare our results. All right, so hit pause. Okay, so let's draw a picture of the stack. We're going to need lots of room here because we've got a whole bunch of pieces of data, and we can expand down if we need to. All right, so here's the stack, and this has a special name. This is called an activation record. And it represents the chunk of memory on the stack for the call to sub. Now, there's a couple of, I'm going to just go from the bottom up. So the first thing we're going to have on here is the return. Let's zoom in here a little bit. The return address. This is the address of the call to sub from some other subprogram or from the main program. So this tells us basically how to get back home after we're done executing the code in sub. This is a dynamic link. When we return to the piece of code that called sub, we also have to reset the stack to the location of the activation record for the caller. So if the main program called sub, we're going to return back to the main program, and then we're going to reset the activation record to the activation record for the main program. And the dynamic link is the location in memory of the activation record for the main program. if the main program is called sub. Okay, so the next thing we have to do is we have to address stuff that's specific to sub. So one of the things is we've got a parameter and that is total. Okay, so that total is this total here. So we're linking total here on the stack. We have another parameter, part, and now we have to deal with local variables that we have. So the local variables that we have are, we've got list, we have to deal with list, and we have sum. Now, what direction, if this is on the stack, what direction does memory grow on the stack? Does memory grow this way on the stack or this way on the stack? This is memory location. This is a smaller memory location here. So this is X, and this is X plus some N. All right. Well, it turns out that memory grows up on the stack. So if memory grows up, and we're building the stack in order from bottom to top, which is how you build up the stack, then the local variables that are on here, this is a local variable. It would make sense that this is list sub 0, local, list sub 1, local, list sub 2, local, list sub 3, local, list sub 4, and then finally another local variable, sum. Okay, so this is the activation record for our subroutine, our subprogram sub. So like I said, I had a hard time understanding or visualizing these activation records. I think for most of you, since you took compilers, the idea of this activation record makes a lot of sense because you had to create your own activation records to get subprograms working in your compiler program. So that's good. So some of this is definitely review. All right, so I wanted to take you through the execution of two different sets of subprograms. The first one just to illustrate how activation records are created for calls to different subprograms, and then the second one to show you how recursion can be implemented using subprograms in the stack. I kind of like the second one a lot because I feel like it helps me understand how recursion works. So if some of you are still struggling with that, maybe it can help you. Okay, so let's take a look at these examples. That's kind of a nice tidied up version of what we just did for what it's worth. And these class notes are available online on the course website. Okay, so let's take a look at this. So we're going to start out with this main program, which is going to call function 2, and then function 2 is going to call function 1, and maybe function 3. And I'm just interested in looking at the activation records for as these calls get made. So we're going to start out with the activation record for main, and there's no return address because main's where everything finishes. But I just want to note that we have a P here that maps to this P. All right, so we've got a local variable. All right, so main is going to call function2 passing in the parameter p. All right, and then that p is going to get copied to R by using call by value. All right, so let's take a look. All right, so now we have an activation record for function2 because we're in function2, and we've got a parameter R, which is going to have the value of p copied to it, a local variable s, and a local variable t. There's the parameter R, there's the local variable s, and there's the local variable t. Now, function2 is going to call function1, passing in s. S is going to get copied to the parameter x. And let's take a look at the activation record on the stack for that. Okay, so now we've got the activation record for function1. So that activation record has a parameter x and then a local variable y. And there's the parameter x and the local variable I. And remember, s gets copied to x using call by value, pass by value. Okay, and then we're going to call function3, passing in y. So now we have the activation record for function3. Function3 just has a single parameter q. Q is getting a copy of what's in, actually I should draw it the other way. Q is getting a copy of what's in y, and now we're basically done with the calls. So after whatever processing happens in function3 happens, we're going to return from function3, and then we're going to remove the activation record for function3 off the stack. And there you see it's now gone. And now we do processing in function1, and then we're going to remove the activation record in function1 from the stack. So the stack's getting a little smaller, less activation records. We do our processing in function2, and then we're going to remove function2's activation record from the stack. And we're back to the end of the program. All right, so I hope that makes sense. So I want to take you through one more, and this is an example of using recursion. So there's our good friend factorial, a real simple type of recursion. And the code, it's a little hard to see here, but the code says value equals factorial of, I think it's hard to read, but I think it's factorial of 3. We'll see in a second as we move down. All right, and so that makes a call to, that's going to make a call to this factorial method, and it's going to pass the value of 3 is going to get copied into that x. So let's see what happens. All right, so we start out with a local variable value in main, but we don't know what its value is yet because we're waiting for factorial to return that value. All right, so yeah, it was 3. Okay, so that 3 got copied to this local, this parameter x. That parameter x is now, I think, well, it says n, but it's really x. Oh yeah, there's an error here. So that x should be an n. Oh, hard to correct it there. Okay, so it's that 3 gets copied to n, and then we have a parameter n on the stack. And we also have a functional value, which we don't know yet. And that functional value is the functional value that's returned from, that we are going to return to the caller. All right, we don't know what the functional value yet is because we have to resolve the code inside factorial. So since n is 3, we're going to skip this and do the else. and we're going to return n times factorial of n minus 1. So that's going to be 3 times factorial of 2. All right, so that is going to trigger another activation record for factorial to get created. This time, we're going to copy 2 into factorial, into the parameter n. So we'll see that in the next activation record display. All right, so now we have a second call to factorial. This time n is set to 2, and it's stored on the stack. So n is set to 2 and it's stored on the stack. So we're going to check, is n less than or equal to 1? Nope. So we're going to do the else, return factorial, n times factorial n minus 1. So let's see if I can do this a little bit better. So this is going to be 2 times factorial of n minus 1, or 1, factorial of 1. So this factorial of 1 is going to get copied to this n. We're going to have a third call to factorial and a third activation record on the stack. This time, the parameter n has the value of 1. All right, so this is where things start rolling back and we start getting some answers. All right, so n is less than or equal to 1. Yeah, n is 1 this time. So we're going to return 1. So that means that the functional value here changes from question mark to 1. And we can return that back to the caller. All right, so, oh, I'm showing that functional value being changed to 1 there for the third call to factorial. Now we can return that back to the caller, and let's look at what happens. So we had 2 times factorial. I can do this a little bit better. So we have 2 times factorial of 1. This factorial of 1 was, the value for that was returned from the previous activation record, and that has a value of 1. So now that's 2 times 1, which equals 2. And that allows us to set the functional value for this second activation record for factorial to 2. And then we're going to return that to the first call to factorial. So the first call to factorial is 3 times the factorial of 2. And we determined that the factorial of 2, based on the previous activation record functional return value, was 2. So that's 3 times 2, which equals 6. So we're going to set the functional value to 6, which is fantastic. And now we're going to take that functional value of 6, and then we're going to turn it to this factorial of 3 call. And then this becomes 6, and that allows us to set the local variable value to 6. All right, awesome. So that shows you how subprograms and stacks and the stack works with activation records.